Introduction. Since the dawn of time, humanity has lifted its gaze to the stars, wondering what lies beyond the shimmering veil of the night sky. For centuries, our tools were limited: primitive telescopes, fragile rockets, and the courage of explorers who dared to push against the unknown. Yet now, in this very moment, a new companion has entered the stage of cosmic discovery: artificial intelligence. Artificial intelligence is not just another tool in our hands. It is a thinking partner, a quiet observer that learns, adapts, and perceives the universe in ways far beyond the reach of human senses. It scans oceans of data faster than any scientist could dream of, unveiling patterns hidden in starlight, signals buried in noise, and phenomena that might otherwise remain invisible forever. The revolution is silent but profound. AI is transforming every step of space exploration, from the rovers that traverse the dusty plains of Mars to the telescopes that peer deeper into time than ever before, to the spacecraft navigating the distant edges of our solar system. It has become the compass in our search for habitable worlds, the sentinel watching for cosmic dangers, and the analyst that deciphers the whispers of galaxies. In this journey, we will explore how artificial intelligence is reshaping our cosmic destiny. Each chapter will unfold a new frontier, revealing not only the marvels of technology, but also the enduring spirit of human curiosity. As you listen, allow yourself to drift into the quiet wonder of possibility, the awareness that intelligence, whether born of biology or silicon, is guiding us toward the stars. Chapter 1. From Telescopes to Algorithms: The Evolution of Space Exploration. The story of space exploration has always been a story of vision, both literal and metaphorical. For centuries, humans relied only on their eyes, mapping constellations with imagination and myth. The ancients traced patterns among the stars, believing them to be gods, heroes, or celestial guides. But our understanding of the universe remained bound to the limits of human sight. The first great leap came with the invention of the telescope in the early 17th century. When Galileo Galilei raised his modest instrument to the heavens, he revealed moons orbiting Jupiter, craters on the moon, and the vast complexity of the Milky Way. That small tube of glass and metal extended human vision beyond its natural reach, opening a gateway into the true immensity of space. For centuries, telescopes continued to evolve, from simple refractors to the giant observatories resting on mountaintops, each one collecting more light, offering sharper glimpses into the infinite. But there was always a limit. The human brain, however extraordinary, could only analyze so much. Astronomers sketched what they saw, recorded what they measured, and tried to decipher the endless sky with pen, paper, and later with early computers. The volume of data grew, yet our capacity to process it did not keep pace. By the mid-20th century, the challenge was clear. We had the instruments to gather vast quantities of information, but not the means to interpret it all. This imbalance set the stage for a new kind of revolution, one not of lenses and mirrors, but of mathematics and computation. As digital technology advanced, algorithms began to take their place beside astronomers. These early programs could sift through data faster than a human, flagging unusual patterns, calculating orbital paths, and guiding spacecraft with remarkable precision. Still, these algorithms were simple, powerful, yes, but limited to the instructions carefully written by their creators. Then came the spark of artificial intelligence. Unlike traditional software, AI could learn. It could adapt. Instead of relying solely on human commands, it could uncover hidden relationships within oceans of numbers and images, making connections that no human eye would notice. The telescope extended our sight into the universe, but AI began to extend our understanding. Today, the partnership between human curiosity and machine intelligence defines the cutting edge of space exploration. Telescopes like the Hubble and the James Webb do not merely capture light from the stars. They generate torrents of data that would overwhelm even the most dedicated teams of scientists. It is AI that now filters this cosmic flood, isolating the signals worth studying, accelerating discoveries that might have taken decades. In many ways, we are witnessing a continuum, from eyes to lenses, from lenses to computers, and now from computers to minds of silicon. Each step is an expansion of perception, each innovation a deeper reach into the unknown. As the story unfolds, we will see how this silent partner, artificial intelligence, has begun to transform not only how we look at the universe, but how we experience it. The age of telescopes gave us vision. The age of algorithms is giving us wisdom. And together, they are leading us toward frontiers once thought unreachable. Chapter 2. Teaching machines to see the universe. The universe is a vast ocean of light, yet within that light are patterns so faint and subtle that the human eye cannot perceive them. For generations, astronomers have strained to distinguish the important signals from the background noise, the flicker of a distant star, the faint glow of a hidden galaxy, the elusive shadow of a passing planet. Each discovery required patience, time, and sometimes a touch of luck. But with artificial intelligence, the act of seeing the cosmos has taken on an entirely new dimension. Teaching machines to see is not the same as giving them eyes. Instead, it is about training algorithms to recognize patterns, much as our own brains do. Neural networks, the foundation of modern AI, are modeled after the neurons in our minds. When we look at the night sky, our brain instantly distinguishes constellations, stars, and even the faint haze of the Milky Way. AI, in its own way, learns to do the same, but on a scale far beyond human capacity. Consider the challenge of discovering exoplanets, those distant worlds orbiting stars far from our solar system. To the naked eye, even through powerful telescopes, an exoplanet is invisible. Instead, astronomers look for tiny dips in a star's brightness, caused when a planet passes in front of it. These dips are minuscule, often lost amid the natural fluctuations of the star itself. For decades, detecting them required painstaking analysis. Now, AI combs through endless streams of starlight, identifying subtle variations that would escape any human observer. Thanks to this, thousands of exoplanets have been confirmed, revealing a galaxy teeming with worlds, some rocky, some gaseous, some perhaps even capable of hosting life. AI's vision does not end with planets. It can classify galaxies by shape, uncover hidden supernovae buried within crowded skies, and even predict the behavior of variable stars. When the James Webb telescope returns its breathtaking images, AI algorithms are already at work in the background, enhancing details, separating meaningful signals from cosmic noise, and highlighting features that astronomers might otherwise miss. What makes this so extraordinary is not just the speed, but the depth of perception. A single astronomer might spend months analyzing one data set, but AI can process millions of stars in the same time. It learns to distinguish false signals from true discoveries, refining its accuracy with each new observation. Like a tireless apprentice, it never sleeps, never grows weary, and never overlooks a possibility. There is also something poetic about the idea of machines perceiving the universe. They do not see beauty as we do, nor wonder at the colors of a nebula. But in their calculations, in the patterns they reveal, they grant us the ability to witness the cosmos with new clarity. They transform streams of raw data into cosmic stories, allowing human imagination to take flight once more. In this way, teaching machines to see the universe is less about replacing human vision and more about extending it. With every exoplanet discovered, every galaxy mapped, and every supernova recorded, AI becomes an extension of our own senses, an artificial eye that gazes into the infinite, widening the window through which humanity perceives the stars. The universe has always been there, waiting for us. Now, with the help of intelligent machines, we are finally learning how to see it in its entirety. Chapter 3: AI as the navigator of spacecraft. Space is vast, silent, and unforgiving. Every mission that leaves Earth faces challenges that no human could anticipate in full. Distances are immense. Signals from mission control take minutes or even hours to arrive. And the smallest error in navigation can mean the loss of years of work. For this reason, spacecraft need a certain degree of independence, a capacity to make decisions without waiting for instructions from Earth. This is where artificial intelligence steps in, not only as a tool, but as the very navigator of our cosmic journeys. Imagine a spacecraft traveling millions of kilometers away from Earth. A course correction must be made, but waiting for instructions would take too long. With AI on board, the ship can calculate its own adjustments, accounting for gravitational forces, fuel efficiency, and unexpected obstacles. It can act in real time, long before a human engineer receives the data. In this way, AI transforms spacecraft from passive machines into active explorers. Rovers on Mars are among the clearest examples. Curiosity and Perseverance, the robotic pioneers of the Red Planet, navigate landscapes filled with rocks, craters, and shifting dunes. In the past, every movement of a rover required commands from Earth, but delays of several minutes made this process slow and risky. Today, these rovers use AI to analyze their surroundings, plan safe routes, and avoid hazards. They act with a measure of autonomy, exploring as if they were thinking beings, carrying human curiosity across alien ground. The same principles guide spacecraft that travel far beyond Mars. Missions like NASA's deep space probes rely on advanced navigation systems that allow them to orient themselves by observing stars, adjust trajectories, and respond to changing conditions. AI enables these vessels to survive in places where human intervention is impossible, guiding them with an intelligence that feels almost instinctive. But AI does more than keep spacecraft on course. It also optimizes how they function. By analyzing onboard systems, it can detect malfunctions before they become catastrophic, redistribute power to essential instruments, and even repair its own code to continue the mission. In deep space, where help is millions of kilometers away, this ability may be the difference between success and failure. The future takes this even further. Concepts for interstellar probes envision spacecraft capable of fully autonomous exploration, driven by AI that can make discoveries, adapt to new environments, and send back knowledge without ever needing direct guidance. These ships would not just travel on behalf of humanity, they would think and learn as extensions of us, carrying our vision into realms we may never reach in person. There is something almost poetic in imagining a silent probe guided by artificial intelligence sailing through interstellar darkness, alone, yet not alone, its mind shaped by human ingenuity, its mission fueled by human curiosity. As it navigates the emptiness, it becomes more than a machine. It becomes a symbol of what happens when intelligence, whether natural or artificial, dares to seek out the unknown. Artificial intelligence is not just a navigator of spacecraft. It is becoming the navigator of destiny, steering humanity towards places where no one has ever gone before. Chapter 4: Exploring Mars Through Intelligent Eyes. For centuries, Mars has captured human imagination. Its reddish glow inspired myths of war and gods, its surface marked by telescopic illusions of canals and civilizations. But as technology advanced, we came to know Mars not as a world of ancient empires, but as a barren, wind-swept planet, yet one filled with mysteries that could reshape our understanding of life itself. Today, we no longer just observe Mars from afar, we explore it directly, and artificial intelligence has become our most trusted companion on this alien frontier. The rovers, Curiosity and Perseverance, are more than machines. They are robotic emissaries of humanity, carrying our questions across the Martian deserts. But unlike explorers of the past, these rovers cannot rely on real-time instructions from their creators. Mars lies millions of kilometers away, and signals take anywhere from 4 to 20 minutes to reach Earth. This means that if a rover encounters an obstacle, it cannot simply ask for guidance. It must think in its own way and decide what to do next. Artificial intelligence grants this autonomy. Each rover is equipped with systems that allow it to analyze the terrain, detect hazards, and plan safe routes forward. Perseverance, for instance, uses a powerful navigation AI known as AutoNav. With it, the rover can map its surroundings in 3 dimensions, choose a path free of dangerous rocks or sand traps, and drive itself across the Martian surface without waiting for human commands. This ability has dramatically increased the pace of exploration, allowing the rover to cover more ground and gather more data than would ever be possible otherwise. Yet navigation is only part of the story. AI also guides the scientific work of these rovers. Their instruments capture enormous amounts of data, microscopic images of soil, chemical analyses of rocks, atmospheric readings, and even audio recordings of the Martian winds. Artificial intelligence helps prioritize which samples to study, which rocks may hold traces of ancient life, and which areas deserve deeper investigation. In this way, AI ensures that every moment on Mars is spent wisely, maximizing the return of knowledge from a world so far away. Perseverance also carries the groundbreaking Ingenuity helicopter, a small drone that achieved the first powered flight on another planet. Ingenuity relies on AI to stabilize itself, navigate the thin Martian atmosphere, and make decisions mid-flight. Each journey it takes expands the horizons of exploration, scouting terrain ahead of the rover and proving that flight is possible even under alien skies. The presence of AI on Mars has changed how we think about exploration. We are no longer limited by the slow exchange of signals across space. Instead, our robotic explorers act as intelligent partners, able to adapt to conditions in ways that once seemed impossible. They extend human presence into places where no astronaut has yet walked, preparing the way for future missions. And yet there is something profoundly human in their work. When Perseverance pauses to examine a rock, or when curiosity captures a panorama of Martian hills, it is as if we ourselves are standing there, gazing at an alien horizon. AI provides the intelligence, but it is human curiosity that gives purpose. Together, they weave a story of exploration that stretches across the void. One day humans will walk on Mars, but until then, our intelligent machines are the pioneers, eyes and minds that search tirelessly, revealing secrets hidden beneath crimson dust. Through them, we see Mars not just as a distant world, but as a mirror of our longing to explore, to understand, and to reach beyond. Chapter 5: Predicting Cosmic Catastrophes. The universe is both wondrous and dangerous. Among the stars, immense forces play out, often silently, yet with consequences that could reshape galaxies or threaten life itself. Supernovas erupt without warning. Asteroids hurtle through space at unimaginable speeds, and massive stellar collisions unfold in faraway corners of the cosmos. For humanity, understanding these phenomena is more than scientific curiosity. It is a matter of foresight. And artificial intelligence has become the guardian of cosmic prediction, a sentinel capable of perceiving danger where the human eye sees only light. Predicting a cosmic catastrophe is no simple task. The signals are subtle, the variables innumerable. A star nearing the end of its life may show faint changes in brightness or emit unusual waves of radiation. An asteroid on a collision course with Earth may be hidden among thousands of others, its trajectory influenced by gravitational nudges from planets and other celestial bodies. For decades, astronomers relied on painstaking observation, careful calculation, and at times luck to foresee potential threats. Even with modern computers, the sheer volume and complexity of data often made accurate predictions a monumental challenge. Enter artificial intelligence. By training neural networks on decades of observations, scientists have empowered AI to detect patterns that would be invisible to the human mind. It can track subtle variations in starlight, identify anomalies in vast arrays of telescope data, and simulate countless orbital scenarios in seconds. Where it once might have taken years to model a supernova explosion, AI can generate thousands of potential outcomes, highlighting the most probable and the most dangerous. Consider the study of supernovae, stellar explosions that briefly outshine entire galaxies. These events release unimaginable energy, sending shock waves and radiation across space. Detecting them early can provide invaluable insight into the life cycles of stars, but predicting them is a challenge of near impossible complexity. AI, trained on the light curves and spectral data of countless stars, can recognize precursors that hint at an impending detonation. In doing so, it transforms our understanding from passive observation to active anticipation, allowing humanity to prepare for or study these cosmic events in unprecedented detail. Asteroids and comets present a different type of danger, one closer to home. Our solar system is filled with countless rocky travelers, many of which remain uncharted. AI assists in scanning the skies, tracking the motion of these objects, and projecting their paths with astonishing accuracy. By modeling gravitational interactions over decades or centuries, AI can highlight potential threats long before they approach Earth, giving scientists time to devise mitigation strategies. Beyond immediate threats, AI also explores the more subtle, long-term catastrophes, the slow decay of stellar systems, the collisions of galaxies, or the shifting patterns of cosmic radiation that could influence planetary environments. Each analysis is a step toward understanding the delicate balance of forces that shape the universe, and each prediction underscores the remarkable ability of intelligence, both human and artificial, to anticipate the rhythms of cosmic time. Yet there is something quietly poetic about this work. The machines do not feel fear or awe, but in their calculations, they offer humanity a form of cosmic foresight. They turn uncertainty into knowledge, chaos into patterns, and distant danger into actionable insight. In this way, AI becomes not only a tool of science, but a bridge to understanding the universe's hidden rhythms. Through the watchful eyes of artificial intelligence, humanity begins to see the universe not just as a place of wonder, but as a complex, dynamic system, where every star, asteroid, and cosmic explosion is part of a vast tapestry. We learn to anticipate its storms, respect its power, and marvel at the precision with which the cosmos operates. AI grants us the gift of foresight, reminding us that in the infinite expanse of space, knowledge is both survival and wonder. Chapter 6: Mining the Skies, AI and the Search for Resources. As humanity reaches farther into space, the concept of exploration begins to blend with the need for survival. Planets and moons may be distant, but asteroids, those wandering stones of the solar system, present a unique opportunity. They are rich in minerals, metals, and rare elements, the very building blocks that sustain technology on Earth. Yet, identifying and accessing these resources requires precision, patience, and intelligence, qualities that artificial intelligence brings to the cosmic table. Asteroids vary widely in composition and size, from tiny pebbles floating through space to massive bodies hundreds of kilometers across. Some are primarily rock, others metallic, and a rare few may contain concentrations of precious metals such as platinum, gold, or even water ice that could support future human colonies. To extract these resources safely and efficiently, we first need to locate them, classify them, and predict their behavior, tasks that AI excels at. Advanced algorithms scan the heavens, analyzing the motion of thousands of asteroids, mapping their orbits, and predicting how they might shift over time. Machine learning systems evaluate spectral data from telescopes, revealing the composition of these distant rocks without ever touching them. Subtle variations in reflected light, invisible to human eyes, are interpreted by AI as signatures of iron, nickel, or even volatile compounds that could fuel rockets. Once potential targets are identified, AI guides robotic probes to these celestial bodies. These machines can autonomously navigate to an asteroid, land on its uneven surface, and conduct in-depth analyses, all while communicating back only essential data to human teams. In some experimental missions, AI-controlled drones are even capable of selecting the most promising areas for extraction, ensuring that every effort yields maximum value. The applications extend beyond mining alone. Water extracted from asteroids could be converted into hydrogen and oxygen, providing fuel for spacecraft traveling deeper into the solar system. Rare metals could revolutionize technology on Earth or in orbiting stations. In essence, AI is enabling a new kind of cosmic economy, one that depends on intelligence, precision, and the careful stewardship of resources in a delicate environment. Yet this venture is not only about utility, it is also a profound expansion of human perspective. Where once we looked at the night sky and saw distant points of light, AI now allows us to envision the material wealth and possibilities hidden among them. Each asteroid mapped, each mineral identified, is a step toward understanding that space is not just a canvas of beauty, but also a landscape of opportunity, shaped by laws we are only beginning to grasp. There is poetry in the thought of machines roaming the silent paths of the solar system, analyzing rocks billions of kilometers from Earth, and translating their findings into knowledge that guides humanity. Through AI, the search for resources becomes a meditation on intelligence, both artificial and human, and a reflection on the ways we extend our reach into the universe. Mining the skies is not simply about extraction. It is about insight, discovery, and partnership. By combining human curiosity with the analytical power of AI, we unlock the hidden treasures of the cosmos, revealing that even in the emptiness of space, opportunity and knowledge awaits those who dare to look closely. Chapter 7: AI and the Human-Machine Partnership in Space. Space exploration has always been a story of collaboration, but never has the partnership been as profound as the one forming today between humans and artificial intelligence. For decades, astronauts relied on mission control, manual calculations, and instinct to navigate the unknown. Now, AI offers a new kind of ally, one that observes, learns, predicts, and assists in ways that enhance human capabilities while respecting the fragility of life in the cosmos. Long-duration missions, such as those to Mars or the outer planets, present unique challenges. The psychological strain of isolation, the complexity of life support systems, and the ever-present risk of technical failure demand constant attention. In these conditions, AI becomes more than a tool, it is a companion. Intelligent systems monitor vital signs, alert crews to subtle health changes, and can even recommend behavioral adjustments to maintain mental well-being. Through subtle interventions and continuous analysis, AI acts as both guardian and advisor, helping humans endure the extremes of space travel. But the partnership extends beyond biology. Spacecraft and habitats are increasingly autonomous, yet they rely on human oversight for decisions that require judgment and context. AI handles routine operations, such as monitoring equipment, adjusting energy systems, and optimizing resource use, freeing astronauts to focus on exploration, experimentation, and creative problem-solving. The machine learns from experience, while humans interpret, guide, and refine its actions, a feedback loop that grows stronger with time. Robotic assistants aboard spacecraft exemplify this collaboration. These machines can perform maintenance tasks, operate delicate instruments, or even respond to emergencies faster than a human could. Yet they do so under the guidance of crew members who provide intuition and ethical reasoning that AI alone cannot replicate. The result is a synergy where human creativity meets computational precision, enabling feats that neither could achieve alone. Training for these partnerships also begins long before leaving Earth. Astronauts work alongside AI systems in simulated environments, learning to trust the insights of machines while maintaining authority over critical decisions. The bond is built on mutual understanding. AI processes vast amounts of information with relentless focus, while humans bring judgment, empathy, and adaptability. Together, they navigate uncertainty and embrace the unknown, preparing for challenges that no single species or machine could face alone. In scientific exploration, this collaboration opens doors to discoveries previously out of reach. AI can propose experimental paths, identify anomalies, and even suggest hypotheses for human evaluation. The cycle of observation, analysis, and discovery accelerates, driven by a partnership that extends the capabilities of both mind and machine. Each success reinforces the profound potential of coexistence in the harshest environment imaginable. The human-machine partnership is more than strategy. It is philosophy. It reflects a vision of exploration that honors both the ingenuity of humanity and the power of artificial intelligence. Through this alliance, we reach farther, observe more deeply, and adapt more readily than ever before. The cosmos, vast and indifferent, becomes a shared space, navigated by an intelligence that is part human, part machine, and entirely dedicated to discovery. Chapter 8: Cosmic Data Overload, when AI becomes essential. The universe is immense, and with every new telescope, probe, and sensor, it whispers ever more secrets into the silence of space. Modern astronomy generates a flood of data so vast that no human mind could hope to process it alone. Images of galaxies, streams of spectral readings, measurements of cosmic radiation, all of these pour in by the terabyte, day and night, across observatories and satellites scattered across Earth and beyond. In this deluge, artificial intelligence becomes not merely useful, but essential. Consider the James Webb Space Telescope, a marvel of engineering designed to peer back in time to the earliest stars and galaxies. Its instruments capture astonishing detail, revealing phenomena invisible to previous generations. But with detail comes complexity. Every image contains millions of points of light. Every spectrum contains subtle variations that hint at chemical compositions, distances, and cosmic events. Sorting, analyzing, and interpreting this information by human effort alone would take centuries. AI, however, can perform these tasks in hours, identifying patterns, correlations, and anomalies that might otherwise remain hidden. AI excels at detecting the extraordinary within the ordinary. A faint glimmer in a distant galaxy, a slight irregularity in the motion of a star, or a subtle spectral line can signal discoveries as profound as new planets, exotic elements, or even clues about the origins of the universe. By training neural networks on past observations, scientists teach AI to recognize what is significant and what is background noise, creating a filter that prioritizes the most important cosmic signals. The challenges go beyond observation. The volume of data generated by radio telescopes, deep space probes, and planetary missions continues to grow exponentially. Each project adds layers of complexity that traditional analysis cannot keep pace with. AI systems manage this overload by compressing information intelligently, identifying patterns across vast data sets, and predicting where anomalies might occur. In doing so, they turn potential chaos into coherent insight, allowing humanity to navigate the torrent of cosmic knowledge. There is something deeply poetic in this reliance on artificial intelligence. The universe communicates in signals far too complex for our senses, yet through AI, we are learning to listen. Machines sift through the noise, uncovering the delicate harmonies of the universe, revealing both its beauty and its secrets. Every data set processed, every anomaly flagged, is a step toward grasping the immensity that surrounds us. In the era of cosmic data overload, AI is not merely a tool, it is a partner, a lens that extends human perception beyond its natural limits. It allows us to comprehend the universe not only as observers, but as interpreters, transforming the overwhelming into the intelligible, and guiding us deeper into the mysteries of space than we could ever venture alone. Chapter 9. The Ethical Horizon: Risks and Responsibilities of AI in Space. As artificial intelligence becomes an indispensable partner in space exploration, it brings with it not only extraordinary capabilities, but also profound responsibilities. Every decision made by an intelligent system, every autonomous action taken on a distant planet, carries consequences that may extend far beyond the immediate mission. In this uncharted territory, humanity faces questions that are as complex as the cosmos itself. How much autonomy should we grant to machines? What risks are acceptable when AI operates beyond our direct oversight? And ultimately, what ethical obligations do we hold as creators of these intelligent explorers? Space is a realm of extremes, where a single miscalculation can endanger equipment, lives, or even the success of centuries-long missions. AI, for all its power, is not infallible. Algorithms can misinterpret data, learn biases, or make choices that humans might consider reckless. The farther these systems operate from Earth, the more critical their decisions become, because guidance from mission control may arrive too late. Ethical frameworks must therefore accompany technological advances, ensuring that AI acts in ways consistent with human values while navigating environments that humans themselves have never seen. Beyond safety, there are broader concerns. AI has the potential to alter the very nature of exploration. When a machine discovers an exoplanet or uncovers signs of life on another world, who takes credit for the discovery? How do we balance human curiosity with machine efficiency, ensuring that the pursuit of knowledge does not become a purely automated endeavor, stripped of human reflection and ethical judgment? These questions challenge our traditional understanding of agency, responsibility, and collaboration in the cosmos. There is also the matter of unintended consequences. Mining asteroids, terraforming environments, or deploying autonomous probes could disrupt ecosystems we do not yet fully understand, whether on other planets or within our own solar system. AI, guided by humans, must make decisions that weigh potential benefits against risks, always mindful that exploration is a privilege, not a right to manipulate without foresight. Ethical design, continuous oversight, and transparent decision-making become essential, transforming AI from a mere tool into a moral partner in the grand endeavor of discovery. In the quiet hum of spacecraft systems, one can imagine the tension between freedom and responsibility. Machines operate with precision and speed, yet their actions reflect choices that humans have encoded, implicitly or explicitly, into their algorithms. Each autonomous decision, whether charting a course past a hazardous asteroid or analyzing a sample of alien soil, embodies a fusion of human intent and artificial reasoning. The ethical horizon stretches across this delicate balance, reminding us that exploration is not only a technical challenge, but a moral journey. In ultimately contemplating the ethical dimensions of AI in space is to reflect on ourselves. As we delegate intelligence to machines, we are forced to examine our own values, our definitions of risk, and our vision for the future. The cosmos remains indifferent, vast, and unknowable, yet the decisions we make through AI shape our path among the stars. It is a responsibility that demands foresight, humility, and care, a recognition that the partnership between humans and machines is as much about wisdom as it is about capability. In navigating this ethical frontier, humanity takes another step toward maturity as a species of explorers. With each challenge, each decision, and each reflection, we learn not only how to traverse space, but how to traverse the delicate terrain of responsibility, ensuring that intelligence, both artificial and human, serves the highest purpose of discovery. Chapter 10: A New Cosmic Era. Humanity's Future with AI Among the Stars. Humanity stands on the threshold of a new era. For millennia, we have looked to the stars with wonder, curiosity, and longing. We have sent rockets into space, telescopes into orbit, and rovers across distant planets. Yet now, as artificial intelligence becomes our companion and guide, we are entering a phase of exploration that transcends the limitations of biology alone. The stars are no longer distant mysteries. They are destinations, increasingly within reach, illuminated by the combined vision of human and machine. Artificial intelligence is transforming the way we conceive of the cosmos. It learns, adapts, and anticipates in ways that complement human creativity and judgment. In distant galaxies, AI identifies signals invisible to our senses, revealing the structure of the universe with unprecedented clarity. On planets and moons, it navigates terrain too dangerous or complex for humans to traverse alone, uncovering hidden resources and preparing the way for future colonization. In the vast ocean of space, it acts as a guide, interpreter, and partner, extending our reach across the solar system and beyond. Yet the true power of this new era lies not only in capability, but in collaboration. Human curiosity fuels questions, imagination shapes purpose, and ethical reflection guides decision-making. AI provides the analytical rigor, processing speed, and insight that make these ambitions achievable. Together, we are creating a symbiotic relationship one where exploration is guided by both intuition and intelligence, by both wonder and calculation. The cosmos, once indifferent and remote, becomes a landscape in which our partnership with machines allows us to act meaningfully, responsibly, and creatively. This era also challenges our understanding of identity and agency. As AI takes on more autonomous roles in space exploration, it prompts reflection on what it means to be human in a universe that is increasingly mediated by artificial minds. Yet rather than diminishing humanity, this partnership elevates it. We are no longer bound by the limitations of speed, distance, or perception. With AI, we can explore, understand, and even shape our cosmic destiny in ways previously confined to imagination. The future of space exploration promises missions that are more ambitious, more daring, and more profound than ever before. Interstellar probes may venture into neighboring star systems, autonomous rovers may terraform alien landscapes, and AI-driven telescopes may uncover phenomena that redefine physics as we know it. In every scenario, intelligence, both human and artificial, works in harmony, pushing the boundaries of what is possible. And yet, amidst all this technological marvel, the heart of the endeavor remains profoundly human. It is our desire to understand, to reach, and to connect with the universe that gives AI its purpose. Without human curiosity, intelligence alone would wander aimlessly. Without AI, human exploration would remain constrained by physical and cognitive limits. Together, we embark on a journey that is as much about discovery as it is about partnership, a journey that redefines what it means to navigate the cosmos.
Conclusion. As we conclude this journey through the cosmos, it becomes clear that artificial intelligence is more than a tool. It is a companion, a guide, and a bridge between human curiosity and the infinite universe. From telescopes that extend our vision, to rovers that explore distant planets, to algorithms that anticipate cosmic events, AI has become an integral part of our exploration. Yet this journey is not merely technological. It is philosophical, ethical, and profoundly human. In partnering with artificial intelligence, we confront questions about responsibility, agency, and the nature of discovery itself. We learn that exploration is not only about reaching distant worlds, but about understanding ourselves, our values, and the possibilities of collaboration between mind and machine. The universe remains vast, mysterious, and indifferent to our presence. But through intelligence, both human and artificial, we are able to perceive patterns, predict events, and act with foresight. Every discovery is a testament to what we can achieve when curiosity meets computation, when imagination meets precision, and when ethics meet innovation. As you reflect on these ideas, imagine the future that awaits. Spacecraft guided by intelligent minds, telescopes deciphering the secrets of distant galaxies, and explorers, human and machine alike, charting a path through the stars. The universe is no longer a distant abstraction. It is a shared frontier shaped by the partnership of minds willing to learn, adapt, and dream. Ultimately, the story of AI in space is the story of humanity itself. Our desire to understand, our courage to explore, and our capacity to extend our reach beyond the limits of our biology. As we continue this journey, one question remains open, inviting reflection. How far can we go when human curiosity and artificial intelligence work together among the stars? The answer is as limitless as the universe itself.